Given a non-empty array of positive integers, determine if it can be divided into two subsets with equal sums. Take the array 1, 5, 11, 5. The total sum is 22. We want to split it into two groups that each sum to 11. Can 11 stand alone? Yes. Do 1, 5, and 5 add up to 11? Also yes. Our goal is an efficient algorithm that can decide this for any valid input. Here is the key insight. If the total sum is odd, a perfect split is mathematically impossible, so we return false immediately. But if the sum is even, we can rethink the problem entirely. Can any subset of the array sum to exactly half the total? For our example, that target is 11. This is the classic subset sum problem, and we solve it with a Boolean DP table that tracks every reachable sum. We build a two-dimensional Boolean DP table. Rows represent how many items from the array we have processed. Columns represent candidate sums from 0 to 11. A cell holds true if we can form that exact sum using some subset of the items so far. With no items yet processed, only sum 0 is achievable. Row 0 is our base case, and dp00 starts as true. Now we process the first item, value 1. For each target sum j, we can either skip this item and inherit the previous row's value, or include it and check if j-1 was achievable before. Since dp00 was true, sum 1 becomes true. All other sums from 2 through 11 stay false. After processing value 1, only sums 0 and 1 are reachable. Processing value 5. Sum 5 becomes reachable on its own, and sum 6 by combining 1 and 5 from the previous row. Now we process value 11. Scanning backwards from j equals 11, we check if sum 0 was reachable before adding this item. It was. So dp11 becomes true in row 3. That is our answer. We have found a subset summing to the target. Since dp at the target equals true, the partition exists. The subset containing just 11 sums to 11. The remaining elements 1, 5, and 5 also sum to 11. We process the last value 5 as well. Filling row 4, dp10 also becomes true here. Time complexity is O of n times target. We can reduce space from O of n times target down to just O of target using a one-dimensional rolling array. The complete one-dimensional solution. Compute the total sum and immediately return false if it is odd. Set target to total divided by 2. Initialize a Boolean DP array of size target plus 1 with only dp0 set to true. For each number, iterate j backwards from target down to num. At each step, update dpj to dpj or dpj minus num. After all numbers are processed, return dp at target.